Look at your everyday life and imagine your life without your mobile phone, your TV, or even your bedside light. All of these contain electrical components that are soldered into an electrical circuit on a printed circuit board. All electrical components need to have a complete circuit to make them work. This is a printed circuit board that contains discrete components all working together. All of these materials have to be conductors as they need to let the electricity to flow through them. For example, copper is used for wire to join the components together. Insulators, such as plastic, are used to coat the wires. They don't let electricity through, so keep the wires away from the components they aren't supposed to touch. Voltage is the power from the cell, battery, or the mains that pushes the electric current around the circuit.
Resistors are used to control the current in a circuit so that they don't damage the delicate components. Resistance is measured in ohms, and a larger resistance means less current in the circuit. Transistors are the electronic switches. A small current is used to switch on a large current. For example, in a heat sensor, a small current passing through a thermistor switches on a larger current through a transistor to power a cooling fan. A capacitor stores a charge and does not let an electrical current pass across it. The amount of charge that is stored is rated in farads. For example, in a camera flash gun, a capacitor is charged by the camera battery, which allows a large release of energy to briefly light the flash tube.
Electronic circuits are described as systems, and each system is made of input, process, and outputs. The electric signal passes from one block to the next, and each block changes the signal in some way to allow the system to produce the required function. For example, in a kitchen timer, you press a switch which starts a timer, and after the set time, this sets off a buzzer. Let's look at the components we need to make a circuit. Remember that you can draw diagrams of your electrical circuits using symbols to represent the components. Input components activate the circuit using an electrical current, and these include switches, thermistors, and light-dependent resistors. Switches are the main input in most circuits and include push-to-make, push-to-break, toggle, and slide types. For example, light switches are usually a toggle switch. A thermistor changes its resistance depending on the temperature. For example, a thermostat in a central heating system. Light-dependent resistors change their resistance depending on light levels. For example, in burglar detectors.
Output devices are the result of the input being processed and include lamps, motors, and buzzers. A lamp is switched on when electrical energy is turned into light and heat, as in toys and security lighting. A light-emitting diode, or LED, can also convert electrical energy into light, and because of their low power consumption and long life, they are replacing traditional bulbs in many circuits. Let's think about your mobile phone or headphones. They have speakers in them for you to hear the conversation or music, with the speaker turning electrical signals into sound. Buzzers can also convert electrical energy into sound and are often found in alarm systems and alarm clocks. Electric signals can also be converted into rotational motion or small movements. Motors in remote-controlled cars convert electrical energy into a rotational motion that powers the cars. And solenoids, or electromagnetic devices, convert electrical energy into small, linear movements that you can see in children's toys and in front door locks that require fob keys to get in.
Integrated circuits, or ICs, or chips, are small devices containing electrical circuits with many components. They are used to replace discrete components and perform particular functions, for example, storing data and keeping time. Musical greeting cards use ICs so that they play a tune when you open the card, and calculators use them to do the mathematical operations. Microcontrollers and microprocessors are programmable devices. Microcontrollers are used for a specific function, and microprocessors are multifunction programmable devices. You can use a microprocessor to control complex equipment. One device can control everything, but if the microprocessor goes wrong, all of the systems could be affected, and the cost to replace it could be high.